Start a new video there. All right. So volume. We'll start with just some basic volume. Basic non-calculus volume. Remember how to find the volume of a cylinder? So let's say you have a cylinder and the radius of that cylinder is 1 foot. How do you find the volume of the cylinder? Do you remember?
You find
The area of the top and then multiply by the height, right?
yeah.
So the area of the top, what's the area of a circle? Pi r squared, and multiplied by the height. So I guess we need the height of my cylinder. We'll call the height 1 also. I don't know, just 10? I don't want to do 10. Okay, 2. We'll go 2. The height is 2. So the cylinder is equally wide as it is tall. So my volume would just be pi times 1 squared times 2. So I'd get 2 pi for my volume, right? Woohoo, easy deal. So now we're going to think about this in a different way. Let's turn our cylinder on its side.
That's not.
And let's pretend that I'm going to put an x-axis right through the middle. And I'm going to put a y-axis right here at the beginning. And I'm going to say my cylinder extends from x equals 0 to x equals 2. And again right here, that's 1 and that's 2. Same cylinder, isn't it? Do you agree? The height is 2, the radius is still 1. But here's how we think about volumes in calculus. It's not just take the area of this and multiply by the height. It basically is that. Because let's imagine that I was able to take this cylinder and cut it into thin discs. So I'm just going to cut it up into thin discs. If I could make those discs infinitely thin, well, in other words, take the limit as the width of my disc approaches 0, disc. Could I find the volume of this cylinder? You may be thinking, what? Yeah, imagine if you could take and cut a disc out of the cylinder and then turn it over. What would you have? You'd have a circle, right? If I took one of those and cut it, now I'd have a circle. And if I took infinitely many of those really thin circles and stacked them all together, wouldn't that give me the volume?
Yeah.
Ah. So, if I know the area of this cylinder, but I'm going to turn it this way now and stack it with a whole bunch of them, and add them all together, that'll give me the volume, right? Right? So, can you tell me a way using calculus to find the volume of this cylinder?
Pi squared
Well, yeah, if I want to take a whole bunch of really thin things and add them together from 0 to 2. If x is not approaching anything, x is 2, between 0 and 2.
It's the integral.
It's the integral between 0 and 2.
Are we using limits?
No.
Good, okay.
Well, the limit, it becomes the integral.
Yeah.
Just, it's part of the concept, but it's
Part of the concept, but you're not going to use it. So it's the integral from 0 to 2 of the areas of all these disks. We'll call it a of x dx. Well, what's the area of one of these disks? Pi r squared, right? So I'm going to replace it. It's really the integral from 0 to 2 of pi r squared should be dr. No, it's still dx. That's right.
So A of x equals pi
Um,
r squared.
A of x, yeah, because the area of my circle is pi r squared, right? So now I need to integrate this with respect to x. And that's okay, because this is r constant. Does the radius ever change as I move along here? What is my radius? 1. To make things simple, can I pull the pi out? So pi from 0 to 2 of 1 squared, just 1. What's the integral of 1 dx? Yeah, so I have x from 0 to 2. So I have pi times, plug that in, 2 minus 0. Hey, I get 2 pi. Who would have known? Got the same thing as before. That was much simpler. But we're not going to do cylinders.
We're gonna do odd shapes. and
That,
lines.
yeah, we're going to do odd shapes and crazy things. So now let's do an actual one here. I just made that one. Let's say I think my pen's dying. Let's say I take the line y equals x from 0 to 1. So there's the line y equals x. Alright, slope of 1, y-intercept of 0. And I just go from 0 to 1. I told you we were going to do this problem. Can you find the area of that triangle? Using calculus or using geometry? Let's start with the calculus way. How would you find the area of that triangle?
The integral from 0 to 1.
Integral from 0 to 1 of? Huh?
Of x dx.
X dx. I don't have to, it's top curve minus bottom curve. In this case, there is no bottom curve, so it's just x dx. So, I mean, we could do 1/2 x squared from 0 to 1. So it's 1/2, right? Now, we could also have done the area geometrically. 1/2 base times height. Base is 1. What's the height? What's this point right here? If you know y equals x, isn't it just 1, 1? Or I should just put a 1 there. That's the point. 1, 1. Yeah, base is 1, height's 1. 1 times 1 is 1. Divided by 2, it's 1/2. That's geometry. Alright, so that's just the area of the triangle. Now let's take this triangle and rotate it around the x-axis. And this is what I was going to do in SolidWorks. Have you all used Solid? Are you all in that class?
No.
You've never used, you guys?
I've used it though.
Oh,
with my
just
dad.
you do.
Yeah, and
So you've done revolves?
Yes.
So if I take this triangle and revolve it around the x-axis 360 degrees, what am I going to have? You're going to have a cone. Or a cone-ish shape. So I got this cone now. So
I know that was pretty good.
let's find the volume of that cone. To find the volume of that cone, we're going to use the same idea as before, this idea of cutting it into thin discs. And if I could take those discs and make them really, really thin and then add them all together, we got a volume, right? So we're going to integrate from 0 to 1. What is the area of each disc?
It changes.
Doesn't it change? What's the, okay? I'm going to cut it into disc, right? So what shape does that make when I cut them into discs? And it's a circle again. We will do some that aren't going to be circles. And how do you find the area of a circle?
R squared.
Pi r squared. What is the radius of each of these discs? This is kind of the important part of this whole thing.
It changes from 0 to 1.
It changes as you move along, doesn't it? Okay. So if I'm right here, what's the area of the disk? Or the radius?
Well, it's closer to 1. Well, no, it's.
It's whatever this x value is, isn't it? Doesn't y equal x? So the radius, this length right here, is whatever x equals. Right?
Yeah.
So when x is 1, the radius is 1. When x is 0.5, the radius is 0.5. So what does r equal in this case?
X.
Doesn't r equal x? Isn't it just equal to this equation? My radius is just equal to whatever x is. So my area of my circle really is pi x squared. And that's what we're going to integrate from 0 to 1 to get the volume of that. So integrate pi x squared dx. Pull the pi out. So pi from 0 to 1 of x squared dx. Notice we don't have to plug in r anymore because r changes. Last time r was constant, so it was easy to plug in. Now r changes, so that's why we're integrating from 0 to 1.
So pi times 1/3 x cubed from 0 to 1.
Pi times 1/3 x cubed from 0 to 1. Plug in 0, it's just 0, so what do you got? Pi over 3. Right?
Stop there.
Yeah, we're going to stop the video.